Hi everyone, we are Team Camel Case and we'll be working on the problem statement extraction of data, including voice and images from various social media platforms from the disaster struck areas and provide insights from them to the NDRF team so that they can get a actual look on what is going on the ground level in this crisis in the disaster struck areas. So we come up with our project Anubandh for this problem statement, and here is the dashboard of our project Anubandh. So we'll be explaining our prototype in much more details further in the slides. So yeah, so how we approach this problem statement, we'll be first collecting the data from different social media platforms. Let's say we'll be collecting data from Twitter using the Twitter developer API, and we'll be collecting data from the Facebook and the Instagram using their graph APIs. And we'll be also using web scrapers to collect the data from different crowdsourcing websites that become active during this disaster situations. So our platform will be using a machine learning algorithm at the backend to trace the increased unusual activity in different regions, and like we'll be looking for increasingly viral trends or the viral hashtags and the voice notes or the images, videos to understand that okay, this area is being disaster struck, and we should focus on the ground truth from the disaster struck area. So after we have identified the disaster struck or the crisis struck area, we'll be analyzing the tweets that are being generated from that particular area regarding which people are being trapped at like which people are facing which kind of crisis in that particular region. So we'll be using our deep learning algorithms and natural language processing techniques to analyze this data that is being collected from social media from the different APIs and our web scrapers. So after collecting this data, we'll be trying to classify them into different categories. Let's say um, a tweet or a social media post has come, and we need to classify it into like food shortage, water crisis, medicine needed, clothes needed. In such categories, we'll be classifying the social media posts, and we'll be plotting them on a map using dynamic clusters. So these dynamic clusters, as you zoom into the map, this dynamic clusters split up and give you the accurate location of the person that are being trapped at which particular region. And as you zoom out of the map, these clusters converge with each other, thus giving a macro level view for the NDRF team that in broad view which region they should focus on. So in this sense, these dynamic clusters can provide both macro and micro level management system for the NDRF team. So once a crisis is resolved, the cluster size reduces, indicating that yes, NDRF team has successfully attended that particular issue. Moreover, we also provide some filtering support for the NDRF team. The NDRF team can actually choose that which category they should focus on. Let's say the NDRF team wants to here in the slide, as you can see, the NDRF team wants to see that okay, I need to see tweets from the food crisis regions only, or the regions that are being facing food crisis. So the NDRF team can select this particular checkbox and only see the regions where food crisis is being faced. Apart from that, we also provide the some pinning support. Let's say NDRF team wants to see tweets from a particular news channel or a NGO that is being reporting from the ground level of the disaster struck areas. So what they can do is that they can pin their tweets and see their tweets only. That will be explaining later in our prototypes. So the crisis cluster location, they're also like classified in the severity of the needs. We'll be displaying them in a priority level encoded marker maps. So as you can see, severe is encoded in pink color, moderate is encoded in blue color, and then blue in yellow color, and then in blue color. So we'll be explaining it further in much more detail in later in the slides. So yeah, so locations are also extracted using custom social media bots. So if the location of a particular social media post is not available, then we will be using our custom social media bots to get and fetch the accurate location of the particular tweet or the particular social media post. And after that, providing all the insights, will be also showing the cluster locations alongside the presence of the NDRF teams and camps. So the NDRF can accordingly plan that which NDRF team should attend which particular disaster struck region, so that they can plan optimally, and each and every disaster struck crisis region could be attended properly by all the NDRF teams. Coming to the technology stack, we'll be using NLP techniques for sentiment analysis from the tweets and the social media posts. will be using convolutional neural networks to analyze the images, videos, and the voice notes that are being uh, posted on the social media. And we'll be using React.js for the front end side. All our machine learning computations and deep learning algorithms will be working on a Flask backend. So our Flask server will be doing all the machine learning computations and would be providing the data to the Node.js server through the WebSockets and webhooks. And our Node.js, it will be serving as an intermediary between the Flask server and the React.js front end side. So the Node.js will be serving the data to the client side that will be displayed on the maps and the dashboards that is designed by React.js. Coming to the wireframes,
Taking an overview of our prototype's wireframe that we have designed using Figma, this is the landing page of our model Anubandh. A navigation bar on top with tabs Dashboard, Resources, and Help section are present. Let's have a look at each of these tabs separately. First, the dashboard comprises of a map with priority level encoded marker locations for disaster-struck areas. The color code is based on the level of severity. For example, pink is for severe, yellow is for moderately affected regions. On the left of the screen, we have a live update section where disaster-related posts, audios, videos are shown. And also, the NDRF team has the power to pin the important posts or tweets for a certain celebrity or a certain organization. The left bottom of this page is the highlight section where you can click on any of the markers and the team would get all needed information related to that particular cluster. The next slide. We also have a filter option which is provided by our model where the NDRF team can easily sort regions based on the type of crisis. If there is a water shortage or electricity shortage or there is power cut, the team can choose the type of crisis and then it will get the regions according to that. Next page. We also have a detailed highlights for all camps in the left bottom that once you click a particular camp's red marker, uh, the all the information regarded to that marker location is shown, and this is the resource tab where all the information regarding to the NDRF team is present here. The nearby camps are marked as red and the distribution of tasks is also done from this feature. Once an assigned task is completed, a particular NDRF team needs to fill the status completion section so that the new task can be assigned to them. Lastly, we come to the help section. For all citizens, this tab would help them become aware about their surroundings and will also provide them necessary information before and after the disaster. Informations like the list of NGOs near them, the survival kit, shelter near me, and preventions are really useful in such cases. And we also have a raise your concern tab where the users can directly raise their concerns to the NDRF team. That is it about the wireframe.
Now coming to the use cases, in our Anubandh system, there are primarily two users. One are the people in the affected region and one is our core user, that is the NDRF team. For the people in the affected region, we will be having resources such as the NGO list, survival kits. So the people in the affected region can access those resources through our website. Also, we will be having prevention tips that has to be taken before or after the disaster, and also we will be having the location of the nearest NDRF centers where people can relocate themselves. Also we will be having a section where people can raise their concern, which can be directly seen by the NDRF team. Now coming to our core user, that is the NDRF team, the people in the affected area will be generating a lot of content, a lot of distress signals on the social media sites. All that will be fetched by our APIs, also through our custom bots, and all this be projected to our dashboard where we will be doing analysis of image, video, audio, and text. Through this, we will be generating priority level encoded marker maps, which will be a real game changer for the NDRF team, through which they can micromanage and also macro manage their resources and can strategically use their resources. Also, they can check the status of various teams and camps on the ground zero. Also, they can do the status management of that teams and camps. Coming to a particular NDRF team, they can update the status of their task and they can also be reassigned. if they are left unassigned or have completed their task. Now coming to the showstoppers or dependencies, we will be really dependent on the NDRF real-time database about their resources, teams and camps on the ground zero. Also, we will be requiring data from the social media sites. So for that, we will be requiring unlimited API calls. Also, there can be certain privacy issues, like people don't want to share their exact location. So that can be one showstopper. Also, we will be needing authenticate information about the NGOs to be displayed on the NGO list section. And also there is a concern of the authenticity of information collected from this social media. Shubham, next slide. Now you can see on the left, we have 4 images. On the first image, you can see that we have 2 clusters that are 3.2K and 1.6K. These are on the macro level, which on zooming one step further gets further split into clusters. Like you can see, there is a yellow cluster of 314, 217 and a blue cluster of 4. So you can see as we scale down, the clusters get further divided. Now coming to one level more down, we can see that these clusters get further splitted into more yellow and blue dots. And one level more down, we see there are all blue dots. So these all blue dots are the exact location, exact pinpoint location where there is a malfunction or error. So the NDRF team can direct their resources through that. So all these 4 will serve our purpose of macro and micro management for the entire region.